So, let us do example number 2. Okay. So, in example number 2, this is your entire truss. Okay. It is made up of triangular frames here as shown in the figure. You have a loading of 100 kilonewton and 50 kilonewton, and you have two supports. One support is at A and another support is at E. Okay. So, you have two supports, one at A and another at E. Okay. So, you have two supports, one at A and another at E. Now, let us solve this. So, first to solve this, what is the first step? What I have told you? The first step is to find the support reaction. Okay. So, the first step is to find support reaction. Now, how do you find support reaction? To find support reaction, you will use equilibrium equation. Okay. Now, here see, you will have, since it is a hinge, you will have a vertical reaction and horizontal reaction, and since it is a roller, you will only have a vertical reaction. Roller cannot take an horizontal reaction. So, I have plotted this, but there is no point of plotting this horizontal reaction since there are no forces in horizontal side. If there is, then I will take. Okay. As of now, there are no forces in horizontal direction. So, what I can do? I can take summation of forces in y direction equals to 0. So, what are going up? My RA is going up. Okay. I can say RAY in the y direction, plus REY is also going up in the y direction, right. And what is going down? 100 is going down, so negative. 50 is going down, so negative is equals to 0. So, RA plus RE, this they are in y direction. Okay. So, I am writing YY is equals to 150. This is the first equation, RA plus RE is equals to 150. Now, you need to take a moment. Now, while taking the moment, always remember you should take a moment either at A or at E, okay, because these are the two unknowns. So, you can eliminate one of this unknown by taking a moment at either A or at E. So, I will take summation of moment at A equals to 0. So, see what all forces are there. There is a 100 kilonewton force which is at 2 meter. So, I will write 100 into 2 and it is generating a clockwise moment. Then I have 50 times 4, it is also a clockwise moment. Then I have RE times 1, 2, 2, 2, 6. So, negative RE times 6 equals to 0 because it is anti-clockwise. So, I can write this as 200 and this is also 200. So, 200, 200, 400 goes to the other side. So, RE is equals to 400 over 6. So, 400 over 6 which is equals to, how much is it? 400 over 6. So, it would be 66 point something. So, it would be 66.67 kilonewton. Since you get, once you get REY, okay, you can get RA which is 150 minus 66.67, which comes out to be 83.33. Okay. So, this is your first step to calculate reaction. Once you have the reaction, then the same process as what we have done earlier, you can analyze joint after joint. This was joint A. Okay. This was joint A, we will analyze joint A first. Okay. So, at A you have RA, how much? 83.3, see here 83.3, I have plot this. Then we do not know what is the force here. So, I will take a force in this direction, okay, going out of A. I will consider both of them out of A. Okay. Initially, I will consider both of them out of A. If something is negative, then I will change the direction. Okay. So, initially I will consider out of A. So, FAG, that is force from A to G, and then FAB, force from A to B. Now what is this angle? Okay, since the sides are equal, see all the three sides are equal, 2 meter, 2 meter, 2 meter. So it is an equilateral triangle, and in an equilateral triangle the angles are 60 degrees. Okay, so this angle is 60 degrees. So theta is 60 degrees. So no need for doing tan theta cos theta, directly you can understand this. Or if you want to solve this, hypotenuse is 2, this is 1. So you can take hypotenuse, sorry, you can take opposite over hypotenuse, sorry, adjacent over hypotenuse, which is cos theta, which is 1 over 2. So you will get 60 degrees. Okay, you can solve it, or if you know in equilateral it is 60, then that is also fine. So now first I will do summation of forces in y direction. What all forces are there in the y direction? You have 83.33 and you have FAB, this is your FAB sin theta, and this is your FAB cos theta. So you have 83.33 plus FAB sin 60. So I will write here, I have 83.33 plus FAB sin 60 is equals to 0. Okay. So what I will get FAB as? FAB would be minus 83.33, this is 83.33 divided by sin 60, which will come out to be minus, that is negative 96.22 kilonewton. Since it is negative, you need to change the direction, pre-assumed direction. Initially you have assumed FAB is going out, but it is not going out, it is towards A, it is coming in towards A. Okay. So this is what it is. After changing the direction, okay, so once you change the direction, you will get FAB as 96.22, which is coming towards A. Now you also need to find FAG. To find FAG, I will do forces in x direction equals to 0. So I will take FAG is going towards right plus, and then this component is FAB cos 60 and FAB is negative. Okay, so I will write it down, FAB cos 60 is equals to 0. So my FAG is equals to negative FAB cos 60. So what is my this? So this would become FAG is negative 96.22 cos 60, which comes out to be equal to 48.11 kilonewton. Okay. Since it is positive, there is no need to change the direction. That means it will remain in the same direction. So at joint A, if you see at this point A, okay, what all you have? You have a reaction, okay, you have a reaction of 83.33, which is coming from down. Okay. So at this point at joint A, you have a reaction of 83.33, which is coming from down. You have FAB. Initially we assumed it was going out, but since it is negative, we have to assume that it is coming towards A, and it is equals to 96.22. Similarly, you have FAG, which is going out, and the direction we don't need to change because it is positive. So it is 48.11. Okay. So this is at joint A. So I will go to the joint A of my diagram. Okay. So I will go to the joint A, and here it is coming towards A, which is it is 96.22, and it is going away, this is 48.11. Okay, that's what we got. Now remember, in the last example, which was a simpler example, we understood that forces are equal and opposite in a member. So in this member from A to B, there would be one more force which is going towards B, because they should be equal and opposite. So this should be towards B, and it is 96.22. Similarly, you have a force which is going away from A, similarly in this member A to G, you will have a force going away from G, which is 48.11. Now, if you can recollect, in our previous example, we have clearly mentioned if forces are going towards the joint, it would be compression, and if the forces are going away from the joint, then it should be tension. Okay, so this would be under compression, okay, and this would be under tension. So once you solve this joint A, now you can again see which joint you can solve. I can solve joint B, because at joint B there is a force of 96.22 which we have just seen, which is just calculated, which is coming towards B. So this force of 96.22 is coming towards B, and there is a force. Now there are members, right? So there would be a force of FBC and there would be a force of FBG. Initially I am taking they are going away. If they come, means if we find out that they are negative, then we can change the direction. Okay, initially I keep it simple, I keep it going away from the joint. Okay, so I have drawn this joint here. You can also simply draw this joint like this. Okay, remember what are the forces? 96.22 coming towards B, and these two I am taking away because they are unknown at present. Okay, so here, so 96.22 it is coming towards B. Since it is inclined, I have resolved into sin theta and cos theta, that is horizontal and vertical component. FBC you don't need to resolve since it is horizontal, but FBG it is inclined, and I have I have taken as FBG cos theta and sin theta. Okay, so let us do it step by step. So same method you need to do summation of forces in y direction equals to 0. Okay, whatever going up is positive, so 96.22 sin 60 is going up, and this is going down. So I will write negative FBG sin 60 is equals to 0. Okay, so my FBG would be 96.22 sin 60 divided by sin 60. So this would become 96.22. It is positive. Okay, it is positive, that means no need to change the direction. Okay, so this FBG is nothing but 96.22. Similarly, I can find out summation of forces in x direction equals to 0. So in x direction, if you see, I have 96.22 cos 60 here. See, if you can see here, I am marking it out. So this is in x direction. Also I have this in x direction, that is plus FBG cos 60, and then I have FBC is equals to 0. So I will write FBC is equals to, okay, this is 96.22, this is negative 96.22 cos 60. FBG was how much? Again 96.22. So negative 96.22 cos 60. So finally I will get FBC as negative 96.22 kilonewton. So it is negative. That means you need to change the direction. Okay. Always remember this, whenever you get negative, you need to change the direction. So at joint B, so I will write this as joint B. Okay. So what is there? A force coming in, how much it was? It was 96.22. This was found in earlier joint A. Okay. Then what we found out now, FBC. FBC initially we took away from the joint, but it is negative, so I will take towards the joint. So FBC is like this, which is 96.22, and FBG it is positive and it is going away, so I will keep it like this, which is 96.22. So I just need to go to the joint B and plug in these values. So this is towards and this is going away, so I will just plot it here. This is going away, which is 96.22. This we need to change the direction. So I have changed the direction, I have made it as 96.22, but this is coming towards the joint. Now according to our basic idea that in a member the forces are equal and opposite, so I will make an equal and opposite force here, which is 96.22, and here also, since it is going towards B, there would be a force which is going towards C, which is 96.22. Now again remember the concept of compression and tension. So if the forces are going towards the joint, it is compression, so the top portion is in compression, this portion is in tension because they are going away from the joint. Okay. Similarly, I will analyze the joint G also. At joint G, there is a 100 kilonewton force going down. There is a force of 96.22 which is going up. There is a force of 48.11 which is going towards left. Okay. And then there is a force of this member, force FGC. Okay. And then there is a force of FGF. Okay. Now initially I will assume they are going away. So I will take this point and draw this here. See, I have already drawn this. Okay. So you can feel free to pause here, draw this joint B, put these values and see whether my diagram matches to your diagram. Okay. You should always pause and try to solve by yourself and then see whether it matches your values or your diagram, free body diagram. Now see, once you do this, you just need to do summation of forces in y direction equals to 0. So what all going up? 96.22 sine 60 is going up, plus FGC sine 60 is going up, negative 100 is going down. Anything else is there in y direction? I don't think so. So it is equals to 0. So I can directly find out FGC is 100 minus 96.22 sine 60 divided by sine 60, which comes out to be FGC comes out to be close to 19.25 kilonewton positive. So since it is positive, that means your assumed direction is correct. So see here 19.25, I have written it initially. Okay. So this we got 19.25. Now if you do summation of forces in x direction equals to 0, so you will get what all there in the x direction? Negative 48.11, negative 96.22 cos 60, positive FGC cos 60, and positive FGF is equals to 0. So we know FGC is 19.25. Okay, so I will move everything to the other side. So FGF is equals to 48.11 plus 96.22 cos 60 minus FGC, which is 19.25 cos 60. If I solve this, I get FGF as 86.6 kilonewton. Since it is also positive, I will not change the direction, I will keep it away from the joint. Finally, I will draw this diagram. Okay, if you can see, this is my diagram at joint G. I will put these values in my main diagram. So here, if I put these values here, this is 86.6, this is 19.25. Similarly, there is another force 19.25 away from this point, and there is towards also away from F, that is 86.6. Now, since both of these are going away, so this is, both of them are in tension. So this is under tension and this is under tension. Okay. So I have done half of your truss. I hope you have understood how to select each joint and systematically draw a free body diagram, then do summation of Fy, summation of Fx, and you will get your values. This is the basic idea. Now what I am expecting you to do is pause here. Now what you do is solve for joint C, then solve for joint F, then solve for joint D, then you can solve for joint E. Okay, once you do this, okay, you will get all the values. Finally, once you get all the values, this is your final answer. In this answer, what you are supposed to do, you need to show what are the forces in each member. AB we got as 96.2 and it is C, that means compression. BC, there is a force of 96.2 and it is also compression. Similarly, BG, this member BG, there is a force of 96.2 but it is a tensile force. Okay. Similarly, you will get the forces in all the member, and this method is known as method of joint. So, we have completely understood this method. Feel free to pause, solve this, try to match your answer. If in case you have any doubt, feel free to contact me in my contact details. Okay, now let us understand method of section. Okay, so in method of section, okay, now let us understand method of section. So in method of section, what you are supposed to do is, you need to make a section. Okay, you need to draw a section, you need to cut a section out of this entire truss and make it separate from the entire truss, separate it and try to see what are all the forces coming out of the section. For example, if I take this section 1, okay, if I cut this section out and if I only analyze this part of this truss, okay, so what is there at joint A? Joint A, you have a force of 83.33 which we have calculated in reaction. Okay, now after that there is a force in member. Okay, this member is like this, it has been cut, and there is another member like this and it has been cut. So now this force, there would be a force like this. Initially I will assume it is going away, both the forces. Okay, so this was your A, so this would be your force F for force, and this is AG, and this would be force AB. Okay, now this force AB can be resolved into two components, AB cos theta and AB sin theta. Okay, just similar to what we have done to method of joint. Only thing is, in method of section you need to cut a section. Okay, so we can do this now. So the first section is very simple. So I will just do summation of forces in y direction equals to 0. What is going up? FAB sin 60 is going up, and I have plus 83.33 going up equals to 0. So my FAB is negative 83.33 divided by sin 60, which is equals to negative 96.22. Since it is negative, that means our initial assumed direction is incorrect. So you need to change direction. Okay. After that, summation of forces in x direction equals to 0. So what all I have? I have FAG in the x direction plus FAB cos 60 is equals to 0. So my FAG is equals to negative FAB cos 60, which is equals to negative, what was our FAB? Negative 96.22 cos 60, which comes out to be 48.11. Okay. So finally you can draw the diagram here. Okay, at this section A. What is happening at section A? The force is coming towards A from FAB, because initially we assumed away from the joint. Now you need to make it towards the joint. So this force is towards the joint, 96.22, and this force is away from the joint, 48.11. As we have understood, there would be an equal and opposite force. This would be 96.22, this would be 48.11, and this would be, which would be compression and which would be tension, if you remember. So this side, if the forces are coming towards the joint, it is compression. If the forces are away from the joint, it is tension. Okay. Now section 2. Okay, so this is the first section. Now what I will do is I will try to cut this section like this. Okay, so I will try to cut this entire beam like this. So if I drew a section like this, if I only analyze this side of the section, okay, so what all I have? See, I have drawn it here. I have 83.3 something like this. There is a force of 48.1, and then this is the force of FBG sine 60 going down, because initially I am assuming this coming out of the section. So FBC is coming out, FBG is also coming out. So I have resolved this into two components. Okay. Now once you do this, now similarly what you are supposed to do, summation of forces in y direction is equals to 0. So what all there in the y direction? Y direction you have 83.33 which is going up. Okay. So this is 83.33 which is going up, and then you have this FBC, this part going down. Okay. So minus FBG sine 60, since it is going down I have taken minus, so I can write FBG is equals to 83.33 divided by sine 60, which comes out to be 96.22 kilonewton. Okay. So since it is positive, no need to change the direction, so this is 96.22. Similarly, if I do summation of forces in x direction equals to 0, okay, so if I do x direction equals to 0, so this would be FBC plus FBG cos 60 plus 48.11 is equals to 0. If I solve this completely, I will get FBC is equals to, this is negative, FBG is 96.22 cos 60 negative 48.11, FBC comes out to be negative 96.22 kilonewton. Since it is negative, we need to change the direction, that is initially assumed direction is incorrect. So change direction. So finally when you plot, you need to change the direction of FBC. So I have changed it here. See, FBC I have plotted towards the section. This is as usual away and this is as usual away. Okay. So these values I need to put in the diagram. So I will put this in the diagram, the first diagram. So FBC, it is coming towards B and it is 96.22, and it is, so this is towards B 96.22, so it should be also towards C 96.22. This is away from B 96.22, this should be away from B 96.22. This would be under compression and this would be under tension. Then again you need to draw a section. After drawing section 2, you need to draw section 3. You can cut this like this. So there would be a force going out like this, and you need to draw this side of the section. So I will draw this. See here, I have drawn this. If you see here, you have a force of 83.33, a force of 100. Okay. And what all you have in the previous, we got this as 96.22 towards B, and FGC is going up and FGF is going this side. I have taken all outside initially. Okay. Now what you are supposed to do, feel free to pause here, draw the section, take this side of the section and try to draw this diagram. Try to match my diagram with your diagram. If you get similar diagram, that means you are doing well. Okay. So what we are supposed to do, same equilibrium equation we will use, summation of forces in y direction equals to 0. So 83.33 is going up, negative 100 because it is going down, and we have plus FGC sine 60 is equals to 0. So my FGC is 83.33 minus 100, plus negative 83.33 plus 100 divided by sine 60. So I will get FGC as 19.25 kilonewton. Similarly, if I do summation of forces in x direction equals to 0, I will get, since this is going towards left, I will get negative 96.22 plus I will get FGC cos 60 plus FGF is equals to 0. If I solve this, I will get FGF as 86.6 kilonewton. Since both are positive, no need to change the direction. Okay, you can keep it as it is. So I just need to put the values now. What I got, FGC and FGF, and both are positive. So I will put here FGC. Where is my original equation? See here, FGC, G to C, sorry, FGC and FGF. So FGC, I found it out as, where is section 3? Yeah, 19.25 FGC and 86.6. So this is 86.6 and this is 19.25. So this would be 19.25 and this would be 86.6. So this is under tension, this is also under tension. Okay, so now you can draw one more section. Okay, I can draw a section like this. Okay, so if I draw a section like this, again you can either take any one of this side. Okay, so I am continuing the same side of the section. So section 4, if I draw like this, I am evaluating this side. Okay, you can also evaluate this side, it is totally up to you. Okay, there is no compulsion that you should evaluate on this side, you can also evaluate that side. Only see that your number of unknowns should be equal to number of equilibrium equations. Okay, so yeah, so if I evaluate this side, so what do I have here? 83.33, I have 100 and I have FCD. Okay, so this FCD we don't know, so I have FCD. I don't know what is this FCF also, and I do know here the force is 86.6. just now we have found out FGF. Okay, so yeah, I can do again summation of forces in y direction equals to 0. So what all I have in y direction, 83.33 negative 100 negative FCF sine 60 is equals to 0. So I will get FCF. If I calculate this, I will make FCF as the subject. So I will get 83.33 plus 100, negative 83.33 plus 100 divided by sine 60. So I will get FCF as negative 19.25. Since I get negative, I need to change the direction. Okay, that means FCF is not outwards, it is towards the joint. Okay, similarly, if I do summation of forces of Fx equals to 0, so I have FCD, I have FCF cos 60, I have plus 86.6 is equals to 0. So if I solve this, what I will get? I will get FCD, sorry, yeah, I will get FCD equals to, because already I have FCF, I can plug this value in here. So I will get FCD as negative 77. So if I will get negative 77 kilonewton if I solve this. So again you need to change the direction. Okay, so if you are changing the direction, so this will also FCD should also towards the section. Okay, so here see, I have made 77 towards the section, 19.24 towards the section, and 86.6, which was already found out in the previous section, it is away from the joint. Okay, away from the section, not the joint. Okay, so yeah, so this finally I will put there. Okay, so I will write 77 and 19.24 towards the section. Okay, so again I need to know the values. It is 19, sorry, it is 77 and 19.24. So it is 77 towards, and this is 19.24 towards. So this would be 77, this is 19.24. and if the forces are like this should be in compression, this should be in compression. Okay. Similarly, you can make one more section here, cut it like this, okay, and solve it. You will get the force here, you will get the force here, and finally you can make a section here. Okay. So make all the sections, two more section for your, you can work it, you can work on two more section. Okay. Try this as an homework. Okay. Work on these two sections, make a section like this, solve for the force in this two sections, and then make a section like this. Okay, then you can get this one. Okay, so you will get all the member forces, and then you can compare. Either you do it by method of joint or you do it by method of section, your forces will remain the same. You will not get different answers. Okay, only thing is they are different methods, but the final answer would remain the same. Okay, so this is all about method of joint and method of section. Now what you are supposed to do, go through lot of questions, okay, from this section, okay, method of joint and method of section. Feel free to approach me whenever you have any doubt. That's all from this lecture. I will see you in my next lecture. Hope you have a good time. Bye.